In the vast silence of the cosmos, telescopes listen for the faintest echoes of creation. But one night, a signal appeared, a note that did not belong. It should not have been there, yet it would not fade. The strangest signal, one no telescope was ever meant to hear. The universe begins in silence. Across the black ocean of space, telescopes turn their patient eyes toward the abyss, reaching past galaxies, past drifting clouds of dust, past the visible stars into the faintest echoes of time itself. They are instruments built to listen to what should not be heard, the background hum left behind by creation, the ghost of the Big Bang stretched thin across eternity. And in that cathedral of silence, where every vibration is weighed and measured, something appeared, a signal, fragile yet unmissable, etched into the noise like a single note breaking the harmony of a timeless hymn. It should not have been there. No star, no pulsar, no quasar could have sung it into existence. No pattern in known physics could have shaped its persistence. At first it seemed impossible, a trick of the instruments, a phantom born of static and chance. But it did not fade, it repeated, as if the cosmos itself had inhaled and whispered through the circuitry of our machines. The line between accident and message blurred, and with it came unease. Because if this was no error, then it was something the universe never intended. To reveal a sound older than stars, sharper than chance, deeper than silence. This is the story of the strangest signal, one no telescope should have found. If you are new here, join the journey. Like, subscribe, and let's begin. The night was still. The sky above a vault of blackness pricked with ancient stars. And below, on a lonely plateau where air was thin and dry, a machine listened to the universe. It was not a telescope in the familiar sense. No gleaming mirrors pointed upward. No lens gazing at constellations. It was a forest of metal arms, a vast ear tuned to the cold and silent waves that drift endlessly across the cosmos. This was the era when humankind sought to listen not with eyes, but with patience. In Chile's Atacama Desert, in the Australian outback, on the ice sheets of Antarctica, vast arrays of antennas had been raised, designed to strip away the brightness of stars and galaxies and hear instead the faint background murmur of creation itself. It was the music left behind from the Big Bang, the cosmic microwave background, a remnant radiation that filled every corner of space. The mission was simple in purpose, yet monumental in scale. By mapping this faint glow, scientists hoped to unlock a story written nearly 14 billion years ago, when matter and light first separated. Within that map lay the fingerprints of the universe's infancy, the seeds from which galaxies, clusters, and the great web of matter would later emerge. The scientists on duty that night were not expecting anything unusual. Most nights passed in routine silence, punctuated only by the steady hum of cooling systems and the rhythmic sweep of data across computer monitors. They were custodians of patience, archivists of noise, sifting through torrents of radio whispers, to find subtle variations in temperature no larger than a few millionths of a degree. Yet amid the ordinary, the extraordinary sometimes emerges without warning. One of the researchers, a radio astronomer trained in the long tradition of sky surveys, noticed a sharpness in the data that should not have been there. It was not the steady hiss of cosmic background noise, nor the regular pulse of a distant neutron star, nor the brief crackle of a fast radio burst. It was something stranger. A line too precise, a peak too narrow, appearing where the universe should have been mute. At first, it was assumed to be interference. The Earth is never silent. Aircraft transponders, distant satellites, even microwave ovens have been known to intrude upon the clean silence of the cosmic background. Entire research careers had been spent painstakingly filtering such false signals away. The astronomer flagged it for removal, another blemish in the fragile art of listening. But the signal returned. Night after night, with instruments pointed toward the same region of sky, it appeared again. Its strength wavered, yet its pattern remained consistent, like a thread woven into fabric too vast to unravel. The team gathered, eyes fixed on monitors glowing with data streams. They ran calibration tests, checked connections, recalibrated instruments. Yet each time the sky was opened, the anomaly whispered back. It seemed to come from a region beyond the galactic plane, a dark patch of sky where no star shone bright enough to drown it out. That emptiness should have been silent. Yet there, amid the void, a note rang clear. For context, humanity had long known the universe was not entirely quiet. Radio astronomy, born in the 1930s with Carl Jansky's accidental detection of galactic static, had revealed pulsars spinning like celestial lighthouses, quasars flaring from galaxies so distant their light was older than Earth itself, and the afterglow of the Big Bang, faint yet everywhere. Each of these discoveries had begun as anomalies, strange blips on chart paper, spikes on early detectors that seemed too irregular to trust. The discovery of pulsars in 1967 had even been jokingly nicknamed LGM-1, Little Green Men. Because the first repeating radio pulse seemed so precise, it was mistaken for an artificial beacon. Yet time and investigation had revealed their true nature. Collapsed stellar cores spinning at impossible speeds, releasing radio waves like metronomes of gravity. This new signal, however, bore no resemblance to pulsars or quasars. It lacked their predictable timing, their explainable frequencies. It did not drift like a satellite or scatter like atmospheric noise. Instead, it persisted with an elegance that unsettled even the most cautious minds. The scientists argued quietly into the night. Some insisted it was surely interference, an echo of terrestrial origin that had not yet been eliminated. Others pointed to its consistency, its stubbornness across instruments and calibrations. It should not exist, and yet it did. As dawn approached, the signal remained unresolved, logged into the archives alongside notes of doubt and skepticism. It was filed under unclassified anomalies, a category filled with whispers that often led nowhere. But something about its clarity, its refusal to vanish, marked it as different. Days turned into weeks, and the anomaly remained a quiet companion in the data. It was easy to dismiss, and yet impossible to ignore. Young researchers pored over it late at night, running simulations, comparing it against catalogues of known cosmic phenomena. Senior scientists advised caution, reminding them of history's lessons. How many strange signals had turned to dust under the weight of careful scrutiny. Still, the unease lingered. In hushed conversations, some began to ask questions that veered into speculation. What if the signal was not interference, but something woven into the very structure of space-time? What if the universe, in its silence, had allowed a single thread of information to slip through? It was too soon to say. Science demands rigor, patience, and the courage to doubt even one's most hopeful visions. But that night, the night the signal first appeared, would be remembered. It was the moment when silence broke, when a machine built to map ancient echoes stumbled upon something that should not exist. The desert air had been still, the stars unwavering, the instruments unchanged. Only the universe had shifted, ever so slightly, in a direction no one could yet name. And in that fragile crack of data, the mystery began. In science, strangeness is often expected. The cosmos has a history of surprising its observers with pulses, flashes, and eruptions that seem at first to border on the absurd. Yet even within this legacy of anomaly, the signal that emerged from the depths of radio silence carried a quality that was deeply unsettling. Its frequency sat adrift, far from the familiar bands of cosmic emission. It did not echo the hiss of hydrogen, whose spectral line at 1.42 gigahertz serves as a cosmic fingerprint across the universe. It was not the cry of molecules drifting between stars, nor the crackle of charged particles moving through magnetic fields. Instead, the signal occupied a domain where no natural process was expected to operate. It was sharp, as if carved with precision, a solitary peak in the endless landscape of noise. Energy levels compounded the mystery. They were neither faint enough to dismiss as random interference, nor strong enough to arise from the great engines of the cosmos, not from pulsars, not from supernovae, not from quasars. It existed in a liminal state, too structured to be dismissed, too anomalous to be explained. Scientists who first examined it drew comparisons to history's great mysteries. In 1967, Jocelyn Bell Burnell had uncovered the first pulsar, a signal so precise in rhythm that she briefly wondered if it could be the work of intelligence. The WOW signal, captured in 1977 by Ohio State's Big Ear radio telescope, had carried a similar air of impossibility. A sudden, narrow band, burst so clean it seemed to defy natural origin, yet so fleeting it vanished before follow-up could confirm it. More recently, the skies had erupted with fast radio bursts, millisecond-long flashes of energy so powerful they rivaled the output of entire galaxies. Each of these anomalies had sent shockwaves through the scientific community. Yet this signal was stranger still. Unlike the WOW signal, it did not vanish after a moment's brilliance. Unlike fast radio bursts, it did not flicker unpredictably. Unlike pulsars, it did not march with the steady rhythm of rotation. It lingered, persistent, stable, as though placed deliberately in the cosmos. That persistence was the source of both wonder and dread, for if it was real, then no astrophysical catalogue could contain it. No supernova, no collapsing star, no magnetized neutron remnant could account for such a signature. It was, in every sense, an impossible note in the orchestra of the universe. The debates began almost instantly. In sterile conference rooms and on late-night calls across continents, astronomers dissected the anomaly. Was it the byproduct of human technology, a wandering satellite, a distant transmitter bouncing against the ionosphere? Yet cross-checks revealed no such match. The frequency did not align with known communication bands, nor with the habitual chatter of orbiting machines. Moreover, the signal had been captured by multiple instruments separated by vast distances, each one confirming what the other had heard. Papers were drafted, circulated, then hesitated over. To publish an anomaly was to risk reputation. The cautionary tales were well known. In the 1990s, a mysterious microwave-like signal plagued one observatory for years, only to be traced back to a laboratory's lunchroom microwave oven. In 2015, a tantalizing alien megastructure hypothesis had been raised around a flickering star, only for dust to later provide the mundane explanation. Science remembers such missteps with brutal clarity, and yet the anomaly resisted dismissal. The first wave of attempts to rationalize it relied on atmospheric effects. Could ionospheric scintillation, the trembling of Earth's upper atmosphere under solar winds, have sculpted a false pattern? Models were tested, but none could reproduce the signal's clarity. Others suggested interstellar scintillation, the twinkling of distant radio sources as their waves passed through turbulent gas clouds. Again, simulations faltered. The pattern was too clean, its persistence too unwavering. Some proposed exotic astrophysics, perhaps an as-yet unclassified magnetar flare, or the remnant vibration of a neutron star collision. But here too, the physics did not align. Such phenomena are violent, transient, chaotic. The signal was steady, measured, almost serene. The contradiction deepened. By all known rules, it should not exist. Nature is chaotic in her processes. Even the most rhythmic pulsar drifts over time. Even the most brilliant burst fades. Yet this anomaly was disciplined. It was as though the universe had spoken in a voice both precise and impossible. Meetings grew tense. At international gatherings of radio astronomers, the signal lingered in the background, like an uninvited guest. Some dismissed it outright, unwilling to risk credibility on something so fragile. Others leaned forward in fascination, compelled by the possibility that this might be the long-sought crack in the universe's armor, the point where known physics gave way to something new. The language of the debates oscillated between restraint and awe. Terms like narrowband anomaly were used in print, though in private some dared to call it artificial. That word carried weight heavier than data. It implied intent, structure, and perhaps intelligence. To suggest such a thing without proof was to wander into perilous territory. Yet the whisper persisted, unspoken in papers, but murmured in halls. The tension between excitement and caution grew unbearable. The history of astronomy had shown that nature's strangeness is often mistaken for design. Pulsars were once LGM1. Quasars were thought impossible until they were not. Even fast radio bursts, once too wild to believe, are now catalogued by the hundreds. To leap too quickly was to risk being wrong before the eyes of the world, and so the community balanced on a knife's edge. In the archives, the signal sat, clean, undeniable, yet unexplained. In discussions, it was both dismissed and defended, ridiculed and revered. To some, it was an echo of error, destined to dissolve into banality. To others, it was a message, deliberate or accidental, from a realm beyond comprehension. The shock was not merely that it had been detected. The shock was that it remained, refusing erasure, refusing dismissal, insisting upon its presence like a riddle etched into the fabric of spacetime. And with that, the scientific world stood divided between the comfort of known physics and the unsettling possibility that something had slipped through the silence, a signal no telescope should ever have found. When the first tremors of anomaly appear in science, the instinct is always the same: to test, to verify, to doubt. The signal was no longer a fleeting curiosity. It had persisted, threaded through nights of observation, and now it demanded the attention of a wider arsenal. The world's telescopes, both on Earth and in orbit, were quietly summoned into a common task: to listen, to watch, to decide whether the universe itself had whispered something new. The search began with radio, arrays, for it was in their domain that the anomaly was first uncovered. Vast networks of antennas spread across deserts and mountain plateaus align their ears toward the same region of sky. From the sprawling dishes of the Very Large Array in New Mexico, to the sharp sensitivity of the Parkes Observatory in Australia, to the frozen isolation of instruments buried beneath Antarctic ice, all were trained upon the silence where the impossible note had been heard. The logic was clear. If the anomaly were terrestrial, if it were born of human interference, then no two observatories half a world apart should hear it alike. Satellites drift, aircraft pass, transmitters pulse, but their signals scatter unevenly across Earth's surface. Yet when the data was gathered, the anomaly appeared again, faint, yes, but present. Each dish, each array, caught its fragile tone. Filtering became the next great challenge. Every anomaly must be stripped of the possibility of error. Computers and algorithms were tasked with dissecting the stream of information, removing the familiar clutter of Earth. Known satellite bands were excised, aircraft transponders eliminated, radar pings carved away, the restless buzz of human technology silenced. Still, beneath the careful erasure, the same sharp crest remained. Cosmic rays were considered next. High-energy particles born in the violence of stellar explosions, capable of striking detectors and leaving false traces. But such impacts were random, chaotic, singular. They did not repeat. They did not linger. The anomaly was something else. And then came the harmonics. When its spectrum was examined with finer precision, faint echoes appeared, overtones that rose like shadows above the fundamental frequency. Not random noise, but structure, as if the signal carried layers upon layers of hidden order. In nature, harmonics emerge when a system resonates, in the vibration of strings, in the oscillation of atoms, in the pulses of stars. But the harmonics here did not match any known astrophysical source. They were too clean, too evenly spaced, as if written in a code not yet understood. Optical telescopes were turned to the same patch of sky, their mirrors capturing starlight that had traveled for billions of years. They searched for counterparts, flashes, flares, or luminous bodies that might anchor the anomaly to something visible. Nothing appeared. The void remained dark, empty of galaxies bright enough to account for the signal's strength. It was as if the cosmos had sung without showing its face. Space-based instruments joined the investigation. The Hubble Space Telescope swept its gaze across the coordinates, its sharp vision piercing through the dim haze of interstellar dust. The Chandra X-ray Observatory searched for high-energy emissions, hunting the ghosts of black holes and neutron stars. Even the Fermi Gamma Ray Space Telescope looked for the violent flashes that accompany the universe's most extreme events. All reported silence. The anomaly belonged only to the radio spectrum, nowhere else. The persistence of this isolation only deepened the mystery. Natural phenomena rarely confine themselves to one narrow band. Supernovae roar across the spectrum, from radio waves to gamma rays. Pulsars shine in radio, but also in visible light and X-ray bursts. Quasars blaze with energy across every possible window. Yet here was something that chose to exist in one place only, a voice speaking through a slit so narrow it seemed deliberate. Scientists returned again and again to their data, applying new filters, new statistical models, new simulations. Machine learning algorithms were trained to sift the noise, to search for repetitions too subtle for human eyes. And patterns did emerge. Faint repetitions, not in time, but in frequency, as though the signal was weaving a rhythm not by beats, but by tones. It was unlike the ticking of pulsars or the staccato bursts of fast radio storms. It was more akin to a scale, a rising and falling ladder of frequencies, too ordered to dismiss, too enigmatic to claim as proof of anything. The meetings grew more urgent. Teams across the globe began to compare notes. Papers were drafted, circulated privately, hesitant to enter the public eye. The history of false alarms loomed like a shadow. To publish too soon was to risk humiliation. To stay silent was to risk losing the chance to claim discovery. Between these poles, science hovered, careful and cautious, yet unable to turn away. The emotional weight was felt most by those who had devoted lifetimes to the quiet work of listening. They had heard the hiss of hydrogen clouds, the crackle of distant quasars, the whispers of the cosmic microwave background. They knew the language of the universe's static. This was different. This was as if the cosmos had spoken a word in a language too faint to translate, a word not belonging to physics as they knew it. And so, the deeper the investigation, the deeper the silence around it became. The anomaly refused to yield, refused to reveal whether it was error or revelation. Each test, each filter, each attempt at dismissal only polished it sharper, clearer, undeniable. In that stubborn persistence, unease grew. For if the universe had placed a voice into the void, then it had chosen a medium fragile enough to be almost missed, yet strong enough to defy erasure. It was as though the cosmos itself had left a mark not for clarity, but for confusion, a riddle carried on waves older than the human species, now caught by instruments that should never have found it. Science, by its nature, waits. But beneath, the patience, a quiet sense of awe began to grow. For in that one impossible signal, the unknown pressed close, nearer than it had in generations. And it seemed, for a moment, that the universe was not silent after all. It began with whispers inside the data, small irregularities at the edges of the anomaly. At first they seemed like artifacts, faint distortions that could be dismissed as noise. But as weeks passed, those faint shadows grew sharper, revealing qualities that should not exist at all. The signal carried a kind of temporal paradox. In its structure, embedded like a watermark, was a spectral fingerprint that seemed impossibly ancient, older than the very universe that contained it. When its harmonics were mapped against the cosmic microwave background, scientists noticed a disturbing echo. The background radiation, the oldest light we know, born 380,000 years after the Big Bang, seemed to resonate faintly with the anomaly's rhythm, as though the signal had been humming across the void long before galaxies had formed. If true, It meant something older than time itself was leaving its trace upon the instruments of the modern age. The claim was extraordinary, and extraordinary. Claims demand resistance. Researchers attacked it from every angle. They checked the calibrations of detectors, reprocessed raw data streams, and searched for terrestrial contamination, satellites, ionospheric bounces, and ground-based transmitters. All were tested as suspects. One by one, each was ruled out. Then came the moment that changed everything. Reports surfaced almost simultaneously from observatories scattered across the planet. A radio dish in Chile, another in South Africa, one more in the deserts of Australia. Each detected the same strange pattern, at the same frequency, pulsing with the same impossible steadiness. The world's scientific community was forced into a collective pause. No single machine could be blamed. The signal was not a glitch. It was everywhere and nowhere, arriving across continents as if stitched into the very fabric of the cosmos. Its persistence grew more unsettling. Natural signals, whether from pulsars, magnetars, or the mysterious fast radio bursts, tend to flicker and fade, their rhythms shaped by turbulence and cosmic violence. Yet this anomaly resisted decay. Its structure held fast, as though maintained by an invisible hand, too precise to be random, too unpredictable to be mere order. It occupied a liminal state, balanced between chaos and design, a whisper threading the line between the familiar physics of stars and the unknowable mathematics of something beyond. Inside conference halls, debates turned uneasy. Was this a new category of astrophysical phenomenon, hidden until now by the limits of our technology, or was it evidence of something that defied even that? A clue that the equations describing the universe were only fragments of a deeper, unseen reality. The more it was studied, the darker the mystery became. Analysis of its spectral spread showed no Doppler shift, no telltale stretching of frequency that comes when a source moves relative to Earth. Almost everything in the universe carries such a shift. Stars orbiting galaxies, galaxies drifting, apart in cosmic expansion. But the anomaly stood still, as if detached from motion itself. A sound unmoored from the rules of space and time. If this were true, then its origin could not be placed on any map of the sky. It was not bound to a galaxy, nor tethered to a star system. It came from nowhere. And in coming from nowhere, it threatened to unravel the idea of location altogether. The discussions became philosophical, tinged with unease. Some suggested that perhaps the anomaly represented not a source at all, but a crack, a rent in spacetime through which something from outside the observable universe seeped through. Others invoked the possibility of higher dimensional echoes, like ripples cast from a shore we cannot see. The history of science has always warned against premature leaps. Pulsars, when first discovered, were jokingly labeled as signals from little green men. The WOW signal of 1977 sparked decades of speculation, yet remains unexplained. Fast radio bursts were once dismissed as interference before proving to be genuine cosmic phenomena. In each case, the extraordinary eventually found footing in natural explanations. But this anomaly resisted such grounding. It stood like a mirror held up to human understanding, showing only the limits of perception. As the weeks bled into months, a quiet fear settled in among the researchers. If the signal could not be explained by known physics, then perhaps it was not merely a phenomenon to be studied. Perhaps it was a symptom, a tremor from a deeper instability in the foundations of reality itself. Speculation turned to the structure of spacetime. Could this be evidence of quantum fluctuations on scales never before measured? Was it a relic of inflation, a fossil vibration left behind by the universe's earliest instant of expansion? Or something stranger still, a sign that the smooth fabric of the cosmos hides fractures, fault lines along which existence itself might one day tear? Such questions are perilous. They evoke possibilities that stretch beyond data, into philosophy, even myth, yet the signal refused silence. Each night, Instruments across the earth recorded its unwavering pattern, as if the universe had chosen this era, this fleeting century of human observation, to make itself known in a new and unsettling way. For those who listened closest, the feeling was difficult to shake. The anomaly did not feel discovered. It felt revealed, as though it had always been there, waiting for technology to catch up, waiting for human curiosity to open the right door. The cosmos had spoken, but what it was saying, whether a warning, an invitation, or a meaningless hum of nature, remained hidden in the dark. And in that hiddenness, the mystery grew heavier, pressing against the minds of those who studied it. They began to wonder, not only about what it was, but what it meant for physics, for reality, and for the fragile human species now caught listening to a song whose origin lay beyond their grasp. In the long corridors of observatories and the quiet pages of scientific journals, the anomaly became more than a puzzle. It became a mirror held against the limits of human imagination. For every test that stripped away familiar explanations, another door opened toward the unknown. And behind those doors emerged theories that stretched from the quantum fabric of existence to the vast architecture of the cosmos itself. The first whispers pointed toward the quantum world, a realm where emptiness is never truly empty. Physicists wondered if the anomaly might be an echo of vacuum fluctuations, the restless dance of particles and antiparticles that flicker in and out of existence, even in the void. Perhaps what the instruments had captured was not a message in any conventional sense, but the faint tremor of quantum foam magnified to cosmic scales. If so, the signal would not be a voice, but a shadow, the universe murmuring to itself through the jitter of its smallest constituents. Yet the signal carried structure, a persistence that seemed too disciplined for randomness. Quantum fluctuations, though everywhere, are fleeting, chaotic, and without pattern. To stretch them into a melody required something more, a bridge between the subatomic and the cosmic. Some speculated that such a bridge might exist in the fabric of spacetime itself, that the anomaly was the resonance of geometry vibrating in higher dimensions. Others turned their eyes to the horizon of universes. If our cosmos is not alone, but one bubble in an infinite multiverse, then perhaps collisions are inevitable. In such collisions, boundaries may scrape against one another, leaving behind signatures like sparks struck between stones. The anomaly, in this vision, was not born in our universe at all. It was the scar of another cosmos brushing against our own, a trace of foreign physics imprinted into our skies. A collision with a mirror universe, silent yet enduring, carried across aeons, into the listening dishes of Earth. The thought unsettled even the most seasoned theorists. For if the signal was indeed a relic of another cosmos, then the laws of physics it carried might not be ours. It might hum with constants that are alien, symmetries unimagined, mathematics that bends in ways human minds cannot yet follow. In its rhythm could lie a glimpse of how reality might have been had the dice of creation rolled differently. Another hypothesis emerged from the shadows of the unseen. Dark matter, the invisible mass that outweighs all the stars and galaxies, combined remains one of physics' greatest mysteries. It neither emits nor absorbs light, yet its gravitational pull shapes the structure of the cosmos. What if, some wondered, the anomaly was not a signal in the traditional sense, but the whisper of dark matter itself? If dark matter particles carried interactions beyond the standard model, their collisions might leave faint imprints, detectable not through light, but through interference with the fields that pervade space. The anomaly could be a communication of sorts, not from intelligence, but from matter long hidden, revealing itself through resonance. A map written not in photons, but in the language of the unseen scaffolding of the universe. The possibility carried profound weight. To hear the voice of dark matter would be to glimpse the foundation of galaxies, the silent partner that has guided the cosmos since its birth. Yet, it would also mean that human physics, built on luminous matter and familiar, Forces is only a fragment of the full score. The universe might be playing an orchestra in which humanity has heard only a single instrument. Still others searched further back into the first instance of existence. When the universe was less than a heartbeat old, it underwent a burst of expansion known as cosmic inflation, a period when space-time itself swelled faster than light. Inflation should have erased nearly all irregularities, yet it left behind faint scars, ripples in density, fossil vibrations imprinted into the cosmic microwave background. Some proposed that the anomaly was one of these fossils, a relic too, subtle for earlier generations of instruments to detect. A shard of the universe's birth cry, preserved like amber in the structure of space-time. If true, then the anomaly would not only be ancient, it would be the oldest signal humanity had ever captured, older than galaxies, older than stars, older than light itself. But such grandeur invited caution. The history of discovery is littered with echoes mistaken for voices. In 1967, the first pulsar was nearly announced as proof of extraterrestrial intelligence, its rhythm so unnervingly regular that the discoverers jokingly labeled it LGM-1, Little Green Men. Only later was it recognized as the beacon of a rotating neutron star. In the 1970s, the WOW signal briefly lit hope, only to linger in unresolved ambiguity. Fast radio bursts, once considered exotic, are now traced to magnetars and cataclysmic cosmic events. Each anomaly whispers of revelation, and each must survive the gauntlet of skepticism. Yet this anomaly endured where others faded. Its persistence, its refusal to decay into the ordinary, kept speculation alive. For some, it became a messenger, not from life, but from the deeper architecture of reality, a communication from realms where mathematics bleeds into mystery, where equations are no longer descriptions, but incantations. The debates grew fierce. Was it new physics breaking through the veil of the known, or simply misunderstood noise magnified by human longing for wonder? Was it the prelude to a paradigm shift, or another illusion waiting to collapse under sharper instruments? The truth, for now, remained silent. And in that silence, the signal grew heavier in meaning. Like a voice, carried across a canyon with no speaker in sight, it forced humanity to confront its own smallness. The cosmos had sensed something, whether accident or intention, whether chaos or law. And in that faint transmission, scientists found themselves staring at the limits of comprehension. To some, the anomaly was terrifying. To others, it was beautiful. But all agreed on one thing. It was a reminder that the universe is not finished with us. That in its depths, in its shadows, in the hidden structures beneath what can be seen, there are truths still waiting. And perhaps, in the strange persistence of this signal, the universe was reminding its restless children that mystery is not a failure of science. It is its engine. The mystery did not end with discovery. It deepened, demanding sharper ears and clearer eyes, instruments that could stretch human perception far beyond its fragile limits. The signal had survived skepticism and the first waves of analysis. Now, the full arsenal of modern science turned toward it. Telescopes, detectors, and algorithms crafted to pierce the silence of the cosmos. Across the mountains of Guizhou, in the heart of China, the world's largest single-dish radio telescope stood like a listening bowl for the universe. FAST, the 500-meter aperture spherical telescope, had been designed to survey pulsars and fast radio bursts to capture whispers from the edge of time. Its immense dish, cradled within a natural valley, bent the faintest radio, waves toward receivers sensitive enough to detect a spark from billions of light years away. When the anomaly was pointed toward its gaze, FAST sharpened its contours. The signal persisted, faint but undeniable, surviving every filter applied. To the south, in the arid Karoo of South Africa, another instrument listened. Meerkat, a field of 64 dishes spread like a metallic constellation across the desert floor, joined the effort. Unlike FAST's single dish, Meerkat relied on the power of an array, weaving together data streams to reconstruct radio skies with exquisite clarity. Its engineers, already preparing for the vast square-kilometer array to come, devoted time to the anomaly. Again, the signal appeared, steady as a faint heartbeat in the cosmos. In Chile's Atacama Desert, beneath skies so dry and thin they reveal the heavens with crystalline precision, ALMA tuned its millimeter wave receivers. The Atacama, large millimeter, sub-millimeter array was built to trace the birth of stars, to map the molecular clouds where chemistry first awakens. Yet it too was asked to listen for the anomaly. Its hundreds of high-precision antennas aligned, capturing wavelengths beyond the reach of ordinary instruments. What they found was unsettling. Not a single emission line, not the fingerprint of any known molecule, but a persistence that resisted categorization. The signal was not chemical, not stellar. It lay outside the familiar. Even the great instruments of gravity joined the chase. LIGO in the United States and Virgo in Italy were designed to hear the tremors of space-time itself. Ripples from colliding black holes and merging neutron stars. Though their focus was not radio waves, their data offered a parallel test. Could the anomaly correspond to gravitational whispers, as if space-time were vibrating in harmony? The detectors found no direct match, but the absence itself was meaningful. The signal belonged to a realm distinct from gravity's waves, carrying its own strange identity. And on the horizon loomed the square-kilometer array, the most ambitious radio project ever conceived. Built across South Africa and Australia, spanning 2 continents, SKA would create an effective collecting area of 1 square kilometer, sensitive enough to probe the cosmic dawn when the first stars flickered into existence. For many scientists, the anomaly became a quiet priority for SKA's future. If the signal survived into this new age of listening, its secrets could finally be pried open with clarity no previous generation had known. But instruments alone were not enough. The modern cosmos speaks in torrents of data, more than any human could pass by eye. Billions of candidate signals, bursts, and noise fragments flow each night into the servers of observatories. To sift through them, scientists turn to machine learning, training algorithms to recognize the difference between satellite interference, Earth's own technology, and patterns of cosmic origin. Artificial intelligence, designed not with imagination, but with statistical hunger, began to comb the data for hidden structures. In these silent partnerships, computers revealed patterns that human analysts had missed. Harmonics within the anomaly, fluctuations too faint for perception, but insistent within the numbers. The machine could not say what they meant. It could only point, as if marking footprints left in fresh snow, leaving interpretation to those who walked behind. Above Earth's atmosphere, space telescopes added their vision. The James Webb Space Telescope, though tuned to infrared light, offered context, mapping the galaxies and voids surrounding the anomaly's region, tracing its environment in exquisite resolution. Euclid, launched by the European Space Agency, carried its mission further, surveying the geometry of the dark universe, mapping how matter and energy bend space-time across billions of years. Its data hinted at subtle distortions near the anomalies, coordinates, nothing conclusive, but enough to stir curiosity. And further ahead, missions yet unborn carried the hopes of clarity. LISA, the Laser Interferometer Space Antenna, planned for the 2030s, would float in the silence of deep space, listening for gravitational waves far longer than LIGO could catch. Perhaps it might find a cousin of the anomaly in spacetime's hidden tremors. Other visions spoke of radio observatories on the moon's far side, shielded from Earth's interference, where humanity might listen to the universe in true quiet for the first time. Each instrument, each project, added another thread to a growing tapestry. No single device could unravel the mystery, but together, across continents and orbits, science wove a global net. The signal was no longer the curiosity of a single observatory. It had become the shared pursuit of an entire civilization. A faint, echo uniting nations and technologies in common wonder. And yet, the more carefully the anomaly was studied, the more it refused to yield. It carried no ordinary spectrum, no familiar source. Its persistence was undeniable, its nature elusive. Like a voice speaking in a language without translation, it remained there, stubborn, steady, and strange. In quiet moments, some scientists admitted the emotional weight. To chase such a mystery was to confront both the strength and the fragility of human knowledge. Modern science, armed with arrays stretching across deserts, detectors tuned to spacetime itself, and telescopes peering to the dawn of galaxies, still stood humbled before a whisper it could not decipher. And so, the hunt continues. Night after night, dishes turn their faces skyward, computers pass endless numbers, space telescopes sweep their fields of stars. The signal has not faded. It waits, steady in its defiance, daring the instruments of humanity to catch up. Perhaps it is a relic of physics, yet unborn. Perhaps it is the first thread of a tapestry too vast to comprehend. Or perhaps it is only noise, magnified into myth by human longing. No one can yet say. What is certain is this: science has placed its finest tools against the silence, and the silence still speaks. In the faint persistence of that signal lies the essence of the scientific journey. To listen, to doubt, to question, and to never turn away, no matter how elusive the truth may be. For in that faint, impossible whisper, the universe seems to remind its listeners of something profound. That reality is not a solved puzzle, but a vast horizon. That truth lies not in the answers already known, but in the mysteries that endure, shimmering just beyond reach. The anomaly remains unresolved. Despite the towers of data, the terabytes of numbers, and the long nights stretched across observatories, it lingers, unsolved, like a shadow cast by a light unseen. But beyond the realm of instruments and equations, the signal raises questions not of physics alone, but of the human spirit. Why does one unexplained sound from the heavens strike so deeply? Why does a single pulse in the static bring both awe and dread, as if the universe itself had leaned closer to whisper? For millennia, humankind has lived beneath the stars, watching their silence. In Babylon, in Egypt, in Greece, voices were raised to the sky in prayer and speculation. The heavens were a stage for gods, for omens, for myths written in fire. But modern science, though built on mathematics and measurement, still carries the same ache, the same yearning to know if the cosmos contains more than silence. The signal is not just a pattern, it is a mirror, reflecting the fragile hunger of a species that wants the void to answer back. Each repetition feels less like random noise, more like the possibility of dialogue. Yet what if it is not a voice at all? What if the universe itself carries memory, a kind of echoing archive written in waves and radiation? Cosmic background radiation already tells the story of the first fire, a faint afterglow from 13.8 billion years ago. Could this signal be another kind of fossil carved, not into stone but into vibration? Einstein once wrote that the most incomprehensible thing about the universe is that it is comprehensible. But here, comprehension seems to slip away. The signal is too ordered to dismiss, too chaotic to solve. It resists the categories that science has built, standing at the threshold between physics and mystery. It asks whether reality itself might contain languages humans cannot translate. Stephen Hawking pondered what it would mean if another intelligence reached out across the void. He warned of the dangers, but also admitted to the haunting beauty of such contact. Others, philosophers of science, poets of the cosmos, have argued that the universe itself is a text, and each discovery is a fragment of a sentence too vast to read in full. If so, then perhaps this anomaly is not a message directed at humankind, but a line overheard in a conversation never meant for Earth. This thought unsettles, because it suggests that the signal may not be for us at all. It may be the whisper of matter folding upon itself, of dark energy tugging at the edges of space-time, of universes colliding in silence. It may be a mirror, showing not communication but limitation, the fragile edges of human understanding, illuminated by something beyond. And yet still, it inspires. The unknown does not only frighten, it draws. It is the horizon at sea, the cave not yet explored, the equation unsolved but beckoning. The anomaly becomes more than a puzzle of science. It becomes a reminder that mystery itself is a force, one that has carried humanity from the first fires of the Paleolithic into the observatories of the 21st century. If the universe does speak, it does not speak in words. It speaks in the movement of galaxies, in the collapse of stars, in the faint music of gravitational waves trembling through space-time. This anomaly may be part of that greater choir, a note struck not for comprehension, but for existence itself. And so it remains, a mystery unclaimed, neither explained by models nor dismissed by chance, a signal on the edge of meaning, somewhere between silence and song. The cosmos offers no conclusion, only the haunting reminder that it is vast, ancient, and immeasurably strange. It reminds humanity that despite the sophistication of telescopes and theories, they are still beginners, still listeners in the dark. And in that darkness, sometimes, impossibly, the universe sings. The investigation began as a spark of curiosity, a faint anomaly hidden in the static of the sky. It grew into a worldwide pursuit, drawing in arrays of steel, mirrors, of glass, and instruments tuned to vibrations finer than a human hair. Each tool bent toward the heavens, straining to make sense of what should not exist. The signal resisted every explanation. It slipped past filters meant to catch earthly interference. It survived comparison across continents, appearing in observatories half a world apart. It stood stubbornly outside the categories of known physics, neither fully random nor entirely ordered, a riddle balanced on the edge of chaos and pattern. Theories multiplied. Some saw in it the faint signature of quantum fluctuations, echoes from the restless vacuum itself. Others whispered of a mirror universe, brushing against our own and leaving ripples at the border of realities. Dark matter, invisible, yet powerful, was considered too, as though the unseen scaffolding of the cosmos might briefly hum with something like voice. And still others reached deeper back, imagining a relic of cosmic inflation, a fossil vibration born in the very first instant of time. But speculation, however grand, has not resolved it. The anomaly persists, untouched by certainty. Here lies the deeper truth. The story of this signal is not only about the universe, but about those who listen to it, for it reveals something essential about humanity itself, a longing to hear, to know, to connect. A single unexplained rhythm in the sky becomes a canvas for fear and wonder, for the ache of not knowing and the thrill of possibility. Einstein spoke of the deep harmony of the cosmos, a unity glimpsed but never fully held. Hawking dared to ask whether the universe might be stranger than we can imagine. The anomaly becomes part of that tradition, standing as a question that unsettles the boundaries of knowledge. Perhaps it is not a message at all. Perhaps it is a mirror, a reflection of how fragile human comprehension is when set against the vast machinery of the cosmos. Or perhaps it is more, a whisper from realms beyond reach, a reminder that the universe is not only silent, but sometimes, impossibly, it sings. As the instruments continue their watch, Fast in China, Meerkat in South Africa, Alma in Chile, and the vast eyes yet to come, the anomaly waits. The sky does not hurry. The cosmos does not explain. It simply continues, vast and ancient, carrying secrets in waves of light, in shadows of gravity, in signals that blur the line between noise and meaning. And so the story closes, not with an answer, but with an echo. the echo of a question still unresolved, the echo of humanity listening in the dark, and the echo of the universe itself, vast, silent, immeasurable, yet sometimes, impossibly, singing.